Hi everyone, so today we're going to be talking about the fundamentals of battery management. And before I get started, I'm going to talk about a little bit about myself and my journey in this space. So I've been, by the way, I'm Akshay, and I've been in this space since 2008. So over the first thing I worked on was electric bikes, right? And I got a chance to re-engineer different parts of the bike and of the powertrain of the bike, and through that I really got interested in battery systems. And so that I took then from there to my master's at University of Toronto, where I also worked on battery systems and on an actual electric car. So I got to design a impedance characterizer for the electric car. I designed the circuits and the software for it, and actually tested it in an electric car to see the model the impedance of the battery, and that gives a lot of useful information about the health of the battery and the degradation of the cells as they're being used over time. So that was kind of my second pursuit in batteries, and then I went on to working for Tesla for over 3 years, and I worked on the SX and 3 cars, and that was super exciting for me to be there. And at a very it was a time when a lot of things were being developed, and a lot of things the teams were smaller in size, so you got to work on a lot of exciting projects. So I worked on the hardware team as well as the firmware team for battery systems. So a great experience from there. And then MakerMax is what we're trying to do over here is take that knowledge of electric vehicles that I've gained and other team members have over the past years, and try to distill it in kind of these stepwise formats for students, for professionals, and for OEMs across the world that are trying to get more into the EV space. And not just EVs, right? Any type of sustainable operation that uses lithium-ion batteries, or any type of sustainable development that they're working on, we are working alongside them. And so we do that mainly through two things, through products and through courses. But getting on with the topic for today, which is the fundamentals of battery management, there are, over the next 30 minutes, what you will learn is why batteries need to be managed, why lithium-ion specifically needs to be managed, and how do we do it, like how is battery management done, and then kind of take up a few of the common questions that I get a lot from students, from professionals, and from companies all over the world. So I'll take up a few of those questions and then wrap it up in just about 30 minutes. So yeah, let's get started. So the first thing is why battery management, right? So batteries need to be managed because think of it like your expense management, right? Your financial management. You look at money that's coming in to your bank account as your income, your expenditure as the money going out, and then what's remaining are your savings. So that is, you're trying to see how much resources you have left, so you're doing financial management. Similarly, you have to do battery management, but instead of money, you have charge. So you're seeing how much charge is coming into the cell, how much charge is going out of the cell during discharging, and then how much charge is remaining inside the cell. So that is one important aspect of why we do battery management. And having that information can lead to a lot of different things, right? So if you know how much charge is remaining inside the cell, you can predict how long the battery would last. If it's your phone, then it could be how many hours are left, or if it's your car or a bike, it's about how many kilometers you can still go with the charge that you have left. So a lot of useful information can be then given to the user of that product. Now, why lithium-ion specifically, right? So lithium-ion is highly energy dense. It can pack so much energy in a small amount of space, and that is why it is so commonly used in a lot of different devices. We can see it's used in phones, on wireless headsets, in electric cars, electric bikes, even like stationary power storage. So if you're doing if you have a solar field, a field full of solar panels, and you have to store that energy somewhere and then release it to the electric grid later on, you use lithium-ion battery packs these days for it. So that, and even telecom towers, the transmission towers, they have power backups that are more and more switching to lithium-ion instead of running generators. So it's a sustainable option, and because one of the things of it is the high energy density, right? So you can pack a lot of energy in a small space that makes it very usable in all these different applications. But there's one thing about that we have to take care of. If you have so much energy packed in a small space, well, if you're not taking care of that, the mechanical structure that's holding it can be compromised, and then you can have a release of so much energy in a short amount of time, and that can cause, I won't say an explosion, but it'll be violent, right, in nature, and you don't want that in an end consumer product. So that's why we need to manage batteries, a system that is looking after the battery, taking account of how much charge is entering, how much charge is exiting, different parameters of the cell, taking into account all that, and making sure that the battery is safe for operation. So that is why lithium-ion needs to be managed. Now let's talk about how, right? So the how brings us to something called battery management systems. So battery management systems are termed commonly as BMS. So BMS, battery management systems, we need them because of the reasons like we discussed, right? So, but how do they function? What do you mean when you're saying that there's a system managing a battery? Well, if you think about a cell is nothing but a chemical reaction happening inside a mechanical structure. So if you think about, there's three main commonly found forms or structures of cells. So there's a cylindrical structure, right? You must have heard 18650, 21700s, those kinds are cylindrical. Then we have a pouch, right? So pouch cells, and then we have prismatic. So there's three forms. What are these guys? These are nothing but mechanical structures. And inside these mechanical structures, you have the chemical reactions. So the elements inside here are what are performing the chemical reactions, which is the transfer of lithium ions from anode to cathode and back to anode, and the release of electrons out of the cell. That is what essentially is your battery, right? And so if you think about this in terms of now a mechanical structure holding a chemical reaction, how do we take into account what's happening inside it, right? One way is to think of it in chemical terms. So I can put all kinds of sensors inside here, right? I can put a probe inside here that is measuring chemically things like, say, the pH level, or the concentration of lithium ions at the anode or the cathode. So those kinds of chemical things I can measure inside the cell, and that will give me some sort of an estimate of what's happening inside here. But that is really hard to do. The sensors to do that, and the parameters, how do you extract that data and what do you do with it, is complicated. So we don't look at it from a chemical perspective when we're managing the cell. We look at it from an electromechanical perspective. So that is how batteries are managed. And so when you're looking at it from an electric perspective, you must have seen the symbol. You can represent a cell like this. It's nothing but a voltage source. Now, a voltage source with a resistance. So this is kind of the simplest way you can represent a battery or a cell. So how do we look at it electrically? What are the different parameters that we can extract? Because in the end, it's still a chemical reaction. Remember that in the end, let's take the example of the cylindrical cell. In the end, it's still, in real life, it's still a mechanical structure holding a chemical reaction. But now we're trying to bring it in terms of the electrical sense, right? So now here we can use the three top parameters that are used to convert a chemical reaction into an electrical perspective is voltage. So we have voltage, we use current, and we use temperature. So these three things give us an electrical insight into what's happening chemically. Okay, so let's dive into each of these and understand how we do it, right? So let's first look at voltage. So now we have a voltage source here, and we have a resistance. And this is inside the cell, right? So this is what my cell is being represented as. So that is my cell. So if I represent it as a voltage source with an internal resistance, and I have to measure now the voltage, right, of the cell. So this is the terminal, this is the negative terminal of the cell, and this is the positive terminal of the cell. If I connect over here a voltmeter, right, for measuring this voltage, can you see any issues that might arise from that? Take like a few seconds to think about what kind of issues would arise if I connect a voltmeter to a cell like this to measure the voltage. Well, one thing is that we have this resistance here, right? So what would happen if there is current flow? If there's current flow in the circuit, then there's going to be a drop across this resistance in the terms of IR, right? I'm trying to measure V, the voltage, but because of current flow, I'm getting a drop IR. So how do we measure, because we don't have access to this V. We only have access to the outer terminals of the cell. So from the outer terminals, how do we measure voltage more accurately then? Well, one thing we can do is reduce the I. If we reduce the I, the voltage drop IR will reduce. So we will the voltage that we measure here at the terminals will be closer to V. What is the second thing we can do? The second thing we can do is try to reduce this R. But is that even possible? This R is a intrinsic property of the way the cell is constructed and what elements are constituting the cell. So you can't change R, but you can change I. The other thing is there is another resistance here. Whatever your line, there is, if you're using a probe or if this is a actual board that you have this line going on, there's an external resistance as well. Right? On those lines, nothing is ideal. So in all practical applications, any piece of wire will also have a resistance. So you could try to reduce this resistance. That's in your control. So you want to keep R1 lower. Right? So this will then converge, if you think of this as V1. So V1 will then converge to V. So that is essentially what we try to do, and some of the aspects I've touched on, not all of them, but some of the basic aspects I've touched on certain issues of voltage measurement in lithium-ion cells. So now let's talk about current. So to measure current, if you have a load connected here, so the cell will start discharging into the load, and there is going to be a current flow in the circuit. So how do you measure I? This is the second parameter that a battery management system must measure. So how do you measure I? One of the ways we can do it is, in the previous example, we were using this as parasitic resistance, but we're going to talk about this as a actual resistance that we have put. R1 is something that we have put now in the circuit. So R1 is what is called a shunt resistance. So R1 is a shunt. So this shunt, if it is kept quite small, the resistance is kept low, R1 doesn't affect the current flow in the circuit if R1 is kept small. But what we can do is across R1, we can connect a voltage measuring device. So now when current flows in this circuit, we can see how much current is dropping across R1, right? So that will give us V would be equal to I R1. So I would be V over R1. So how do we do that then? So if we have to measure I, we need R1 and we need V. Sorry, this V. Let me say this is V cell and that is V. So I is equal to V over R1, right? So with that we can then measure the current that is flowing inside the circuit. Now, do you see any complications here? The first thing we've touched on already is if this is high, if R1 is high, then it's going to affect the amount of current flowing in the circuit, so you don't want that. Also, if the value is high, it's going to dissipate heat. Like when there's current flowing through a resistance, it dissipates heat. That heat would then change the value of R1. Resistance are temperature dependent. So that will then skew your values for current. So you want to keep R1 as low as possible, but as low as you keep it, you will still have temperature variance. And that temperature is not just because of the current flowing into the circuit, it could also be because of the environmental temperatures. If your product is in a hot environment versus if your product is in a cold environment, your R1, your shunt resistance, is going to change in value, right? So that needs to then, that will change your current reading as well. So that is certain things you need to be careful about when you are using shunt measurement. So what is another form of measurement then? And by the way, shunt is used a lot in a lot of different circuits. So it's not a bad way of measuring current. It's just these things that I'm talking about are something that you have to take into account. Your system needs to take into account for accurate measurements. So what is the other way of measuring? The other way of measuring would be to put what's called a Hall sensor. So there's plenty of devices available in the market that measure, based on Hall sensing, they measure the current flow inside the circuit. And with that, you're not interrupting the current flow. There's not an actual sensor, there's not an actual resistance in the path. There's just a sensor that is checking the change in magnetic field when there's current flow through the wire. So Hall sensor-based sensors will not interrupt the current flow. So there's the temperature dependence issue that we talked about with shunt is much less here. But they're not as accurate because you are kind of remotely sensing. You're not actually in circuit, you're not testing it, you're not sensing the current, it's just testing it or sensing it based on the magnetic field changes. So there will be inaccuracy in that measurement as well. So you have to compare the tolerances and the accuracy of both those types of measurements and see how much accuracy your end platform needs, end product needs, and try to make that decision based on that. So that is current, right? And then the last one is temperature. So for temperature, we can use a lot of different devices to measure the temperature, right? So there is what's called an NTC. There is a PTC. There is what's called thermocouples. There are semiconductor-based and then there's also infrared. So you have a lot of different options of measuring temperature, and each of these have their advantages and disadvantages. For example, NTCs at some point they have an exponential relationship to resistance and temperature. They're nothing but there's temperature controlled resistances. But if you're using a temperature control resistance, it would be nice it'd be nice to have a linear relationship between temperature and resistance of the device that you choose to use. But you'll see that in NTCs, a lot of times there's not a linear relationship. There's an exponential relationship. So that has to be then calculated in a proper way of what is the dependence of what change in resistance of an NTC, what temperature change does that correspond to for your cell, right? So these are a few ways in which you can measure temperature. So now let's talk about, you now have voltage, current, and temperature. You have these three readings in your battery management system. What do you do with it, right? So that's the next thing. So we've understood that we need to measure, electrically, we need to measure these three parameters, but what do we do with it? So we have voltage, current, temperature. So these are going into a system, right? And what do you do with it? Well, if you use voltage independently, right, you can use it independently and you can do things like over voltage, under voltage, right? These are safety checks. With the voltage of the cell, you can check if the voltage is over voltage, which means that it is above the manufacturer specified voltage of the cell. If you go above that value, it is a hazardous place to be for a voltage. Basically, if you're going above that specified voltage, the over voltage limit, it is not good for the cell. And similarly, under voltage. And it depends on chemistry. A lot of times you'll see this is like 4.2 volts. This is around 2.8 volts, but it changes with chemistry. So when you're measuring the voltage, you can then check if it's over voltage and under voltage. The next thing is current. A similar thing, if you're just using current on its own, you can do a over current, right? You can check if the current that's being taken out of the cell or put into the cell is too much. That would cause an over current scenario. And because of the internal resistance of the cell, that will build heat inside the cell. And you don't want too much heat to build up inside the cell, because that's going to harm the cell. So over current is an important thing that the system will measure based on just a current reading. You also have a temperature reading. So over here, if you just look at this kind of on its own, then you can get a over temperature. So these are all safety things that a battery management system, minimum things that it should run for sure. Over temperature will let the system know that the cell is too hot, right? And if it's too hot, then the current needs to be throttled accordingly. Other devices that are connected to the battery need to be told that the cells are getting too hot, so to reduce the consumption of current. You can also have a case where the cell is too cold, and that could be in an actual environment the car is in or another product is in, that it's too cold. So it's not good to extract a lot of charge out of the cell when the cell is too cold. So the cell needs to be heated up if it's too cold. That's also something that a temperature value can tell you. And now you can start combining these values, right? You can start combining them, and you can get things like state of charge, right? State of charge algorithm. So voltage on its own, one of the things we didn't touch on before, voltage on its own is hard to use to figure out how much charge is remaining inside the cell. You can run different types of safety algorithms with just a voltage reading, but when you're talking about when you have to calculate how much charge is remaining, how much longer the cell can go, a simple voltage measurement won't do because of something called polarization, right? So if you combine voltage and current, you can do something called a state of charge, which will tell you how much percentage of charge is remaining inside the cell. Similarly, if you combine a voltage, current, temperature, you can start getting things like state of health, right? So what is how healthy is the cell? How much has it degraded over time? Those kinds of things you can start getting with more complex measurements of the three variables. So you can see how three inputs can give a lot of useful information at the output. So that is kind of the essence of battery management and why we perform battery management. And that is pretty much what I wanted to cover in terms of the technical aspects. Now, I wanted to take up a few questions that come up commonly. And the first one that I hear a lot is, hey, I come from a mechanical background. I don't know how I can contribute to the battery space. I like it, but I feel like I'm not qualified for it. Now, battery systems, like you must have seen through these exercises, it's a combination of mechanical, electrical, chemical, and you could say software or firmware. Right? So all these different fields have a role to play in battery management, right? So this is what is needed to understand battery management. And I've just taken an example of someone asking me if they're coming from a mechanical field, can they do battery management? Well, my answer is this. The fact that battery management includes so many different fields it's super exciting. And that's super exciting personally for me too, because I come from the electrical background. I have experience in electrical and firmware. My expertise has developed over time in chemical and mechanical because of working on battery management. So that is the same. If you start working from a mechanical perspective, at least now you know what are your strengths and what are your weaknesses. So if you are coming from a mechanical background, you know that you have to then fortify your skills in these three areas. So then you can start taking steps towards increasing your knowledge in these areas, increasing your experience in these areas. So it's not that you can't do it. It's just that if you have the right steps to take and you know what, because these are huge fields, right? You don't have to like be an expert in electrical. You don't have to be an expert in chemical. You don't have to be an expert in firmware. But you have to have a system view of how the electrical part of it is working. If you have a system view of how the chemical part of it is working and a system view of how the firmware, software part of it is working, that will make you a very successful battery engineer. So that is my answer on if you're coming not just from mechanical, say you're coming from electrical only and you don't have experience in other areas, that the same thing applies to you, right? You know where your strengths are. Now you start working on your weaknesses, and so that is how you get to be an expert in battery management. So that's the first question I get a lot. The second question I get is, what are certain steps I can take in battery management? Can you tell me where do I start? I'm really interested in the up and coming fields like electric vehicles and power storage, telecom, aerospace. I'm really interested in these areas, and I want to contribute to these areas. I really don't know how to start with battery management. So the way to think about this is you start with any of these four areas, you start gaining hands-on experience. That's how I started with the electric bike, like I told you, right? So that hands-on experience is what is going to really count towards getting to that eventual goal. And because you will learn a lot of things in theory that when applied to real life become very different. And very simply, like an example like we took before, you can think of a voltage source, but you're ignoring the resistance that is inside the cell. If you just think about it in theoretical terms, you're like, oh yeah, a cell is just a voltage source. I measure the voltage, it tells me the voltage, so it's a voltage source. But there is an internal resistance, right? And that is something you learn practically. What is the effect of that internal resistance? You learn practically. How does it change with temperature? You learn practically, right? So those are the things that will really distinguish you from into then getting to that eventual goal of being an expert in battery management. So hands-on experience. Now, if we know that we have to get hands-on experience, that is on its own a broad term. When I started working at Tesla, I was given a 8,000 cell pack to work on all of a sudden. And that was a huge learning curve for me. So I had to break it down, right? How do you learn all of a sudden how 8,000 cells are working when you don't know fully how one is working? And so that's something I recommend for you to do as well. If you're looking at getting better at battery management, is first figuring out how one cell fully works, having a full command over how that one cell works, playing with it, trying to discharge it, trying to charge it, trying to measure different parameters of it, voltage, current, try to see how it polarizes, what is polarization, does it change with temperature? You know, you are experimenting with a thing, right? You think of it as a black box. You don't know, there's a chemical reaction that's happening inside it. Think of that as a black box. Think of it from an electrical perspective. What are the experiments you can run on it to get a better understanding, a better intuition of how it's working? So that is something. You start with 1 and then you multiply that to 10. There's going to be more challenges when you have more cells connected together in certain combinations. So you start with the first, and then you go with 10, then you go with 100, then you go to the thousands, right? So that's how you slowly build your knowledge. And that way, when you get to that thousands, you have a full commandment on what's happening, right? And you'll see the change or the benefit of doing that when you're able to debug a lot of complex issues that happen with so many cells connected together, when you're able to understand how the single unit is working. Now, the one other thing that, one of the things that I also hear a lot is that, hey, I want to get, I'm really short in time. I want to get a job in this space, and how can I quickly get a job in battery technology? Though it comes back to the same thing. It comes back to getting practical experience. There's a huge demand for this space, and it's growing. Right? You're lucky that you've chosen a space that is up and coming. Because it's up and coming, the opportunities are growing every day. There's high demand for engineers and for people who understand battery management properly. So it's great that you found this interest. How do you cultivate it? We've just talked about how you cultivate it on a hands-on way. How do you cultivate it in a way of getting an eventual job in this space? Well, you have to look at then looking at what that job is about, right? Each battery management job is going to be a little different. If you're looking at working for companies that are making electric cars, electric automobiles, then you have to kind of think about that full-scale understanding of how do you go from that one cell, fully understand that one cell, and how do you scale it up. If you're looking at consumer electronics companies that are using lithium ion, then having even just one cell, understanding of one cell is enough to gain a job in that space. A lot of questions you'll hear in interviews about that space are going to be about understanding the different aspects of battery management. And if you can even tell simple things at this point, maybe not simple, but as you develop more intuition, they become simple on just like, for example, that shunt current thing we talked about, right? On how if you have a shunt resistance, how is this value of the R shunt, how is it affected by temperature? if you can show that command over the effect of R shunt over temperature and how that will affect your voltage readings, right, or your current readings, you know, you have a really good shot at getting basically good feedback on that interview and eventually getting that job. So those things are really important. That intuition is really important. That's what you should work on. And finally, I'll just leave you with, I think we're pretty close on time. So what I'll leave you with is, if you have more questions about how you get there and more clarity, if you need more clarity on a specific thing that we've covered today, feel free to reach out to me. I'll put my email up here. So my email is akshay@MakerMax.ca. Okay, so that is my email, akshay@MakerMax.ca. So feel free to reach out to me if you have more questions about what we've covered today, different aspects of battery management, how you can set yourself up for success in battery management. And yeah, we send out newsletters, and we write a lot of different aspects about key things about battery management. Follow us on different social media platforms, and you can get a lot of that information there as well. But yeah, I hope you've enjoyed today's talk, and I look forward to being in touch with you and hearing the projects that you are going to be working on over the coming months to get better and better at your skill set in this space, and let me know how I can help you. Thanks so much.